Hi there. So we're about midway through this chapter P, prerequisite chapter. We're jumping into the next lesson here, and it's over something that you guys learned a great deal about back in Algebra 1. You probably spent a majority of second semester working on factoring polynomials. And when you did it back then, you probably spent, my guess would be a few weeks learning all the different factoring methods, practicing with them, quizzing, testing, and whatnot. So a lot of the factoring understanding is kind of expected, but I am going to go back through all those methods that you guys learned about back in Algebra 1. And factoring is going to come into play a great deal in this course, and it's really important to understand what you're doing, number one, when you're factoring, and then two, how do you go about factoring each type of problem, okay? So what factoring is in general, all right, think about what we did last class. We worked on multiplying polynomials together. For instance, if I said take 2x and distribute it to, 4x squared plus 3x plus 1. If I said multiply these two things together, well, this is what we worked on. You take 2x, you distribute it inside the parentheses, and you would get 8x cubed plus 6x squared, and then plus 2x. All right. So when you're multiplying, you're distributing, essentially. Factoring is the exact opposite of that. What factoring is, you're given a polynomial, and you're trying to think about what was being multiplied to get to that polynomial to begin with. That's the question. What two things were being multiplied to get to this answer? Okay, that's what factoring is. You're trying to think about what was being multiplied. What that means is, in the end, you can check your answers because if you multiply your two things together, you should get back to where you started. So that's what factoring is. And the whole idea is you're trying to break down exponents. It's messy to work with x cubes in an equation or x squareds or whatever. And so what factoring does, it breaks those exponents down and then makes your problems easier to work with in the end. So option one of factoring is called GCF. And this is what we are going to go into every factoring problem looking to do. You look at every single term and ask yourself if there's something that you could pull out of every single term. And so here, I notice that if I just look at the numbers, the 6 and the 4, okay, we're going to treat the numbers different than the variables. Try to think about what number goes into 6 and 4 evenly, and that's 2. So we're going to pull 2 out. And now I have x cubed and x. And I'm trying to take out essentially the same amount of x's from each term that I possibly can. And so I can take out an x from each of these terms. So my GCF is 2x, okay? So I'm essentially factoring out 2x. Well, anytime you factor out a GCF, you're going to have something left over. And so now we have to figure out what was 2x being multiplied by here to get to 6x cubed minus 4x. That's the idea. So to figure that out, take each term and divide it by 2x to see what goes inside of here. 6 divided by 2 is 3. X cubed divided by x is x squared. So if I take out 2x from 6x cubed, I get 3x squared. Then we take this sign, bring it down, and do the same thing. 4 divided by 2 is 2. You had an x, but you removed it, so you don't have any x's left. And there's your answer. So these are the two things that were being multiplied together to get this to begin with. But notice you started with x cubed, and now you got an x squared and an x, easier exponents to work with. And again, you could check this because if you multiply these together, you should get back to where you started. Okay, so you can check pretty much every single factoring problem. So option one, GCF. Is there something you could take out of every single term? All right, next factoring method that you guys probably learned is what's called a difference of squares. So there's going to be really two things to keep in mind with factoring. Number one, what type of problem is it? Like, how do I go about it? Is it a GCF problem? Is it a difference of squares problem? You have to be able to look at a problem and recognize what you need to do. And then the second part is, once you identify that, now you have to know, okay, how do I use that method? So for a difference of squares, understand what this is. This is when you have two terms, all right, two terms. You are subtracting, so you have a minus sign, that's what difference means. Two perfect squares, two things that you can take the square roots of. That's what has to happen for you to have a difference of squares. So if I look at this, I am subtracting two perfect squares, two things that I can square root, if you will. So here's the process or the method. Take the square root of each term. So the square root of 9x squared is 3x. The square root of 4 is 2. You don't have to write those, but I like to. So now I'm going to do two things with these. In one set of parentheses, you're going to have 3x plus 2, and in the other set, you're going to have 3x minus 2. Once you take the square roots, put the plus and put the minus. A mistake students tend to do, they'll find the square roots, and then they'll just put 3x minus 2 as their answer. They'll say, oh, just subtract them. Well, think about what factoring is. This is important conceptually. You need to have something that when you multiply them together, you get back to where you started. So if you just say this is your answer, well, no, this is not the same as what you started with. So that can't be the answer. There's got to be something else. And we have a positive and a negative. And understand why it's a plus and a minus. If I go back through and distribute this, look at what happens. I get 3x times 3x, so 9x squared. I'm going to get minus 6x here and positive 6x here. So those cancel. The negative and the positive cancel. That's why you have a positive and a negative. And then 2 times negative 2 is negative 4. So you do get, when you multiply these, you do get back to where you started, which is the whole idea. So your final answer is this right here. So square root each term, and then add them and subtract them. So there's GCF. There's difference of squares. Now, these two are new. Now let me back up here. You can only factor a difference of squares. You cannot factor a sum of squares. If I said factor x squared plus 9, you cannot factor this. You can't do it. And some people are like, well, why don't you just do x plus 3x plus 3? Well, if you do x plus 3x plus 3 and multiply those out, you get x squared, and then you're going to get a 6x in the middle, which you don't want. So you cannot factor a sum of squares. You can only factor a difference of squares. However, you can factor a difference of cubes and sum of cubes. So this is when you are subtracting two perfect cubes. So we have to know our perfect cubes, like 1, 8, 27, 64, etc. And sum of cubes. And it's the same formula, but a couple differences in signs. So for difference of cubes, and here's what I mean by this. If I had x cubed minus y cubed, all right, x cubed minus y cubed, and let's say I wanted to factor this. Here's your formula. Just like with squares, you square root each term, and then you do something with them. Here, you're going to cube root each term. So the cube root of x cubed is x, and the cube root of y cubed is y. Now what I'm going to do, here's my formula. In my first set of parentheses, I'm going to do x minus y. Whatever those cube roots are, whatever this sign is, your first set of parentheses is going to have that same sign. So that's your first set of parentheses. Your second set of parentheses is this. You're going to square the first cube root, so x squared. Okay, square the first one. Your sign is going to change now. So whatever this sign was to start with, now you're going to put a plus. The sign switches. You're going to multiply your two cube roots together. You multiply x and y together to get xy. Your last sign is always going to be a plus, and you're going to square the second cube root. So here's your formula. You find the cube roots. In the first set of parentheses, you keep the sign. Your second sign switches, and then the last one's always positive. Okay. In the second set, you square the first one, take the product of the two, and then square the second one. And we'll do an example with that. The sum of cubes is really the same formula. You have x cubed plus y cubed. So it works. It doesn't work for a sum of squares, but you can factor a sum of cubes. And it's the same formula, except two signs switch. The first and second signs switch. So in your first set, you're going to have x plus y. And then the second set, you're going to have x squared. The sign now changes, so minus xy. And then the last one's always a plus y squared. And the last one's always plus because when you square this number, no matter if you square anything in the world, it's going to become positive. So that's why that last term is always positive. All right, so let's put this into action. We want to factor 8x cubed minus 27. Okay, step one, identify that it is a difference of cubes. I can cube root 8x cubed, and I can cube root 27. So let's find those cube roots. The cube root of 8x cubed is 2x. Because if I would multiply 2x by itself 3 times, I would get 8x cubed. The cube root of 27 is 3. Now I'm going to apply the formula. So it's a difference of cubes, right, minus sign. So we're going to go to this right here. All right, so here's what it's going to look like. Here's really in our formula the x and the y. So we're going to have 2x minus 3. Whatever those cube roots are, keep the sign. In the second set, you're going to square this thing here. Now be careful here. You're going to square 2x. When you square that, you get 4x squared. Sign changes, so plus. You're now going to multiply these two things together. The cube roots, multiply those together and you get 6x. Plus, square the second one, so 9. When you factor a sum or difference of cubes, whatever's left is going to be your final answer. You're never going to be able to factor any of this more. So that's it. And you can check it. If you distribute this out, you should end up with 8x cubed minus 27. You can check every single factoring method. All right. So that was new. Example 4. So now we're going to factor a quadratic. So that means a squared term. Quadratic means x squared. Trinomial, so 3 terms, with a leading coefficient of 1, meaning there's a 1x squared to start with. There's nothing in front of x squared. And I know different teachers teach different methods, and you guys may have your own strategies for these, and that's fine. However you need to factor. Okay, I'm just going to give you suggestions, but this is completely up to you. So the way I factor this, I'm going to have 2 sets of parentheses. And I'm going to split this x squared up here and here, so x and x. Now what I'm trying to find is 2 numbers that multiply to be negative 30. If I multiply them, I get negative 30. And if I add them, I get negative 7. So I got to find a pair of numbers. If I multiply them, I get negative 30. And if I add them, I get negative 7. And you might need to list out some factors of negative 30. But it's going to be negative 10 and 3. So it's going to be x minus 10, x plus 3. Negative 10 times 3 is negative 30. Negative 10 plus 3 is negative 7. So your 2 numbers here have to multiply to what we call C. It goes A, B, C. A is the number in front of x squared, B is the number in front of x, and C is the constant. So you're trying to find what multiplies to C and adds up to B. And that's right there. And again, you could check it. You can multiply it out if you would like to. Here's where it gets a little bit tougher if your leading coefficient is not 1. Okay? Your first hope is that you could take out a GCF, that you could pull some factor out of every term. Well, I can't. Nothing goes into 5, 13, and 6 evenly. There is no GCF. And going back, that's the first thing I should have looked for all these anyway. Like right here in number 2, I should have looked for a GCF. Nothing comes out of those 2. Here, nothing comes out of 8x cubed and 27. There's no GCF here. But that's the first thing I'm always looking for is, can I pull something out of every term? Well, 5, there's not. So there's 2 ways to do this. You can kind of guess and check, which I can get into if you would like when we talk about our homework next time. I'm going to show you a method. I call it the AC method. And I know different teachers teach different things, but I'm going to call this the AC method. It's kind of a 4-step process, okay? So step 1, we're going to multiply A and C together. Multiply 5 and negative 6 together. You get negative 30. Now we're going to find 2 numbers that multiply to be negative 30 and add up to be 13. Pair of numbers that if I multiply them, I get negative 30, and if I add them, I get 13. That's going to be negative 2 and 15. If I multiply those, I get negative 30. If I add them, I get 13. But you don't do this, don't write this. You don't just put x minus 2 and x plus 15. Here's the most common wrong thing I see people do. And understand why this doesn't work. If I would multiply these together, I don't get this. If I multiply x and x together, I don't get 5x squared. So don't just go right to there. Here's the step that you need to remember. I'm going to rewrite this problem. Okay? My first term stays the same. But I'm going to split up the middle term into these 2 numbers that I just found. Here's what I mean by that. Instead of writing plus 13x, I'm going to write minus 2x plus 15x. So I'm taking 13x and splitting it up into these 2 numbers I found over here. And then minus 6. Okay. Next what I'm going to do is a process called factor by grouping. Now, factor by grouping is when you have 4 terms. 1, 2, 3, 4 terms. Hopefully you learned this in Algebra 1. If not, it's not a huge deal, but here's how it works. We're going to group the first 2 terms and group the second 2 terms. Now you're going to look for the GCF of each group individually. So I look for what can I pull out of here. I can only pull out an x. And I'm left with 5x minus 2. Then I look for the GCF of the second group. Well, I can pull out a 3. And if I pull a 3 out of the second group, I again have 5x minus 2. If you've done this correctly up to this point, you should always, always, always have the same thing in the parentheses here. If you don't, you did something wrong. Either you found the wrong 2 numbers or you pulled out the wrong GCF. You should always have the same thing in the parentheses. Here's what we do next. I want you to look at this term here and this term here and think about what they have in common. They have a 5x minus 2 in common. So basically what I want to do is factor out a 5x minus 2 from each of these. And when you factor something out, you pull it out in front. And then think about what's left if you pull out 5x minus 2. Well, from the first box, you're left with x, and then bring the sign down. And the second group, you're left with 3. This is my factorization. Now, it seems like a long process, but the more you do them, you start to get a little comfortable. Like I said, you may have learned other strategies. There's guess and check. I've heard of people using something called slip, slide, divide, box method. I mean, there's various ways of going about factoring when you have a number in front of x squared. Whatever you're going to do is up to you. Here's a method that will work. Multiply a and c. Find a pair of numbers that multiply to that and add to the middle term. Rewrite your problem, but split the middle term up. And then factor by grouping. Group the first 2 and second terms together, and this should always end up working out. And you'll get your practice in with that. Example 6. Factor the greatest common factor such that the remaining factors have only integer coefficients. This is a type of problem if you have a coefficient that's a fraction, how to deal with this. Well, so what I want to do, any fraction, I'm gonna factor out a 1/2. Okay? Any fraction I see, I want to factor it out. So I'm going to pull out a 1/2. And they also all have x's in it, so I'm going to pull out an x as well. Now I want to see what's left over. 1/2 divided by 1/2 is 1. I have x squared left. Plus, here's where you need to be careful. Your brain sees the 2 and the 1/2, and it automatically thinks 1. It thinks half of 2, but it's not. When you factor out a fraction, you're dividing by that number. 2 divided by 1/2 is not 1, it's 4, because you would do 2 times the reciprocal of this. So you're left with 4x, and then minus, and again, it's not half of 5, but it's 5 times 2. So that'd be 10. No x's left. And you can check, if I would distribute this back through, I would get 1/2 x cubed, good, and then plus 2x squared, good, and then minus 5x. So that works out right there. All right, last 2. So example 7 says factor completely. When you're factoring, it's never really going to say factor this one by GCF, factor this one by difference of squares, factor this way. It's never going to tell you. It's just going to say, or you're just going to have to know to factor. And so you're going to have to identify what type of problem it is and how to go about it. First thing I would do is rearrange these to put it in standard form. All right, so I'm going to put the negative 2x cubed first, positive 2x squared second, positive 4x third. And option 1 in any factoring problem is any GCF you have, factor it out. Now, you might look at the negative 2, 2, and 4 and think, oh, I could pull a 2 out. And that's fine, but you might run into some issues later on. Me personally, whatever's left, I always like my leading coefficient to be positive. So if I'm looking at this, I'm going to take out a negative 2. And then I can also take out an x. And what that does for you is, with what's left, you're going to have a positive coefficient, which is easier to work with. So you're going to have positive 1x squared. 2 divided by negative 2 is negative 1, and then x. And 4 divided by negative 2 is negative 2. X is gone. Now, in factoring, sometimes problems have GCFs, sometimes they don't. Sometimes you could take a GCF out and then factor what's left even more. Like for instance, if I said take the number 20 and factor it, forget about all this. If I said factor 20, you'd probably say, oh, 2 and 10. And then you could take the 10 and factor it and break it down even more. And that's kind of what happens here. Take out the GCF. Now this thing is a quadratic trinomial with coefficient of 1. So let's see if there are two things that multiply to be -2 and add up to -1. I'm trying to find a pair of numbers that multiply to this, add to this. And there are. -2 and +1. If I multiply -2 and 1, I get -2. If I add them, I get -1. The GCF you took out doesn't just go away. It always comes down throughout the work. And then when I factor this, I'm going to have x minus 2, x plus 1. And you could check this. If you would multiply all this out, you should get back to where you started. You can always check these. All right, last one. So I look at this, and there is no GCF. Nothing goes into 16 and 81. There's no x here, so I can't pull any x's out. But then I notice, oh, it is a difference of 2 squares. These are both perfect squares, and I'm subtracting. So let's think about how to do that. Take the square root of each. Square root of 16x to the 4th is 4x squared. The square root of 81 is 9. And then you're going to have 4x squared plus 9, 4x squared minus 9. Remember, you take your square roots, add and subtract them. But wait, there's more, because now if I'm looking, kind of like on the last one, how you can factor this more right here. Well, let's look at if these can factor more. This cannot factor. And hopefully you know it can't factor because that's a plus sign right here. You cannot factor a sum of squares. But you can factor a difference of squares. This is another difference of squares here. This, 4x squared plus 9, just bring it down. It doesn't just go away. It's still a part of your factorization. But this, if I take the square roots of each of these and keep going, this would be 2x and 3. And so then you're going to have 2x plus 3, 2x minus 3. These are not difference of squares anymore. There's no GCFs. That's it. That's it right there, and you are done. I know that seems like a whirlwind and a whole lot of information, but the idea is, I mean, this is called the prerequisite chapter for a reason. The idea is that you guys have background in factoring, and that you are comfortable. At least you've seen this stuff before. Not the cubes. That's new. So you'll definitely practice with that and kind of remembering these little formulas. But once you, and I'll give you a little trick, I think, next class to help you remember that, those formulas there. But you need to know GCF, always look for that. Difference of squares, that should be new, or old, I mean, that should be a refresher. Quadratic trinomials with coefficient of 1, find your numbers that multiply to C and add to B, and just write your answer right off the bat in one step. This is the one here that you're going to have a method to be able to factor this. Everyone's got their own methods. We'll practice this more next time. I'll talk about guessing and checking with you. Some people like to do that, but we'll talk about that in great deal next time. I mean, your assignment tonight is just for you to practice these strategies. If you have questions, don't worry about it. We'll definitely get this covered. Okay. All right. That is all I got. Thank you.